Okay, not COVID,
Yeah,
no,
not COVID.
not COVID. Okay, hi.
Hi, hello.
So Ken Leong is not having COVID because I think it's a flu. This flu, I think, is very influencing,
Yeah.
around the people because we have a lot of people having cough. So again, welcome to our this Sembang AIoT session today. My name is Cecily.
Yeah, my name is Kennel.
So today, if you want to know how, in terms of implementing IoT application, especially those remote site, collecting data from a remote site, running on solar, you need a low power device, and also at the same time, you want your gateway to be able to gather certain data. For example, just a simple contact point, let's say, or just an IO point. Yeah. So if that is what you are looking at, maybe this channel is for you, or this session is going to be for you. Okay, so good afternoon and good morning or good evening, wherever you are. So me and Ken Leong is also, this is our episode number 29. 29, it has been a while. So I hope for some of the people or some of the audience who has followed us, thank you very much. We appreciate very much. And also we want to take this opportunity to wish you a Happy New Year or Merry Christmas to some of you. And especially for those Chinese community, we would like to wish you a Happy Winter Solstice Festival. Yeah, so 冬至快乐. Yeah, use the maybe Chinese because these people never heard you talking in Chinese before.
冬至快乐.
It's a bit. So today is going to be a short one, but it's very special one. So I would like to just start sharing. It's on this on the table. Our listing won't run away from a table. Won't run away from IoT device or AI stuff. This is where we have. This is what we have. This is what we have, and. Okay, I would like to also start with this. I think last week we missed Sembang bukan seberang Sembang.
Kita Sembang technology.
Kita Sembang AIoT. So okay, the very first thing that I want to share is you see I've received quite a numbers of inquiry or some of these some of our customers or some partners. They were looking at certain thing that a system that come with the IO built-in. Yeah. So like for this case, Exomtech, we have this one of the embedded system, or it can be a smaller IoT gateway. Usually it comes with this GPIO. So today I want to share with you how you can make use of GPIO and how this GPIO is important in some of the IoT application. So let's start. So for one of the case, maybe we can share the thing. Yeah, again, this is a number 29, episode 29. So yeah. So in what we call, you see, the very fundamental thing about digital IO or digital IO points, these are the thing that these are the things that we are going to have, in a digital IO point. For example, a digital input or digital output. Some of the very fundamental things that I think most of the IoT implementer you should know. Yeah, most of you know, but I think if let's say you are one of the maybe more ICT person, these are the basic fundamental that I think you should, take a look. If that will be that is useful for you. It's easier, when you come to any troubleshooting. See, in the most of the IoT application, when talk about input, digital output, analog input, analog output, there are certain know-how in terms of electronics that we need to take care. Correct or not?
Yeah.
In terms of connection, in terms of how you want to tap signal to the external world, that is very important. So I hope this very fundamental thing will be able to give you some lights, to further implement your this IoT application more successfully. Okay, so talking about digital input, there are usually two areas. Digital inputs, in terms of electronics, you have this TTL input. Many of the device, for example, why we want to bring this one out also, because all the Axiom Tech standard or even the industrial PCs, it comes with a GPIO. These are all TTL input. Yeah. So when you have a TTL input, you should seldom, you are not able to link some of this equipment directly, because TTL input, basically one of them is they are not isolated, there is no isolation. And when you say when there's no isolation, there will be a chance where you are able to be interrupted by the external equipment which share the same ground with you, or even power surge, things like that. It will affect your system or your IoT gateway or so on. So these are the area where you usually what you will have is this kind of a digital input. And then also you in the digital input for TTL is very straightforward. You know, there is no spatial treatment to it. You know, basically you can see in the circuitry, in the electronics. Yeah, it's a combination of a semiconductor input. You know, just an IC or with some a resistor put across. Like for example, in this case, you can see a 5 volt. Actually, it's a pull up 5 volts. That allow you to give a dry contact to it. Yeah, this allow you to do a dry contact to it. So having this dry contact, you are able to do what? Normally digital input.
Digital input, you can get some with the input voltage.
Yeah, some input voltage. But for this case, dry contact can be a relay output from another system. For example, there is some alarm, alarm system. Usually you have this what they call the alarm signal when you trigger, give you a relay contact. This relay contact can be fed onto this circuitry where it will convert into IoT gateway to take it as input. So using this what they call the TTL is not so good as I told you. There's no isolation. So the next one will be a more industrial one. Maybe you can just click for me, easier. So, okay. That I will come to that later. In terms of NPN and PNP. But then you can move on. We have this isolated input. Yeah. So this isolated input will be more what they call applicable in the industrial world, where these what they call, if you look at the circuit, we can click on and then, okay, yeah. So you can see at the bottom of the diagram there is the optocoupler or opto isolator. Usually the barrier, the isolation barrier is about 3,000 watt or 3.5 kilowatt. 3.5 kilowatt or something like that. Yeah. So that isolation is really break away between the external ground and the internal ground. So that is very important in most of your application, especially industrial application, where you have certain input. For example, some power input, or voltage input. It can be also a dry contact, but more of a voltage input. So that part will able to trigger the optocoupler. You transfer that to the internal circuit. So it's total isolation. This is all about digital input. And then in the digital input, you have this NPN type or PNP. For example, NPN is usually used by Japanese system. Yeah, it's a kind of Japanese system where it give you all standard NPN. But if you go to some European what they call sensors or something like that on the contact, it give you a contact point, or it give you this output. It will give you in the form of a PNP. So if you have a PNP, so your treatment of a PNP is different. Okay, NPN basically is a pull down kind of a 1 to 0 is a pull down, but PNP will be on the source. You need a voltage to trigger it. If you can look at this diagram again, maybe we can blow this up. Yeah. So on the right hand side, PNP output is basically it's actually sourcing in to the input so that you can detect as one of the input. Okay, so let's move on. So after talking about more inputs, then we move to the output. Same thing in the digital output. In IoT application, you have this TTL output as well. Yeah. So let's see what TTL output is having right now. Yeah. So for TTL output, is basically a voltage output. You know, because TTL you only take in or you only source 0 to 5 volts. So when you're talking about TTL level, so for this case, VS actually is 5 volt, and then when you trigger, it gives you the output of 5 volt in the TTL form. Okay, this is also another issue when you don't have isolation. Let's see, from there we have this isolation output type. In the isolation output type, again, it will be instead of the optocoupler right now pointing in, right now is pointing out or pointing out. So whatever triggering in your system or in the IoT gateway or controllers, it will activate the one of the opto transistor. It will not opto transistor, opto diode or something like that. Yeah. So on the isolation barrier, that it will trigger the output. Yeah. This is the more preferred or more preferred way in the sense of application, especially in the industrial, where you want to isolate both your digital input and digital output from the external world. So you see, let me ask you. So if you have this knowledge with you, so do you think it will be helpful for you to how you want to tap on some signal or some sensor from the field?
Yeah, I think so.
So because that also you give you a consider, because some of the equipment or some of the sensor is giving you a voltage output. We call it a wet contact, and some of them is giving you a dry contact, which is a relay form. That actually allow you to know more about how you can do that. Let's move on. So of course, there is a third type of output which is totally isolated. You can just click on. So that one is for total isolation, but it's driven by a relay. Yeah, it's using an electromechanical kind of way to provide a contact to you. Yeah, that is. So when you have these are the three main type of output that is applied in most of the electronic or electrical world. And in this case, if you have an IoT application, same thing. You will have this set of DIO in mind. So okay, so let's move on. So as far as AxiomTech IoT gateway is concerned, we also have this port. If you can see here, from here, there is one port here, a DB9 connectors, where in this case you are able to we are able to access to this I/O. It give you maybe 4 input and 4 output. It's programmable. So that's why you say general purpose is actually programmable output I/O, allow you to what you call access to some I/O in terms of input and output as well. For example, this unit you are linking to somewhere remote beside the river, let's say, beside the river. In the river there, you are detecting certain things, for example, in terms of level of the sensors, things like that. So you want to trigger an alarm, or you want to trigger a siren, yeah, or you want to provide another point to another set of equipment to do whatever thing that he need to do. But then by using this, you do not need to have another I/O module, so-called. So that actually is quite a cost-saving design where everything is built in. I think if you refer to some of our AIS, the AI suite, we have this AI Edge. We are also making use of the I/O.
Oh, yeah.
We are also making use of I/O. So in that part, maybe I want Ken Leong to share something. How do you interface to this local I/O?
Okay. So for this, actually we have the library to controlling the I/O, and then we also add on for you so that you can use the MQTT to trigger the I/O. Either you want to configure the I/O become an input or output.
Yeah. So internally, actually, is the API that you need to use, right? Because ExamTech do provide an API. Let's move on. So it gives you another API. Okay. For example, for this case, what do you think? Now what do you think is this digital I/O from our gateway? Is it a TTL or is it isolated I/O for this case?
This case, TTL.
Yeah, it's a TTL. So it's a TTL. That's why today I want to talk about this topic is because there are many query about this set. Nowadays it's very competitive. People want to make use of something that is already available. They don't want to add on more things. Yeah. So the sinking current, when we talk about TTL, that's why I say it's not very practical in some of the case. If you're using a dry contact, it's okay. Yeah, it's just a dry. The sinking current sometimes is kind of limit. If let's say you accidentally, did not put any pull-up resistor or a resistor in between, will feed in the voltage directly or 5 volts, something like that, it will burn the it will burn the digital input port. So sinking current is limited to 5 to 8, 5 to 10 milliamp, usually, and then the voltage level is going to be 5 volt. Yeah, and as you know, in most of the industrial application, they talk about 24 volts. So sometimes it's not very applicable. So in this case, what will you have? Yeah, you move on to the other. So in order to use some of these things, we have this daughter board. Yeah, we have this one of the daughter board. This daughter board will convert for you a 4 digital input and at the same time also the other 4 relay output. That will be very useful already. Yeah. So in fact, AIS, when we do this development also,
we already integrate this one.
We already integrated. So for AIS, let's say you build a model, you detecting certain thing, but then you also, for example, you are using this guy, we have this camera fit into this box. So what happened is when you apply our AIS edge, we have some inference engine running. So the I/O point linking to the external daughter board is already linked. So you can practically trigger the points and also capture certain input as well. For example, sensor, people passing by, you want to do snapshot, things like that. That is already available. So that is the whole thing about digital input and digital output. I don't know whether I have something more. I think yes, I have to. So by using that's a question that I posted to Ken Leong. So let's move on to the other page. So for example, using our IoT gateway, we have this node, you want to run on node rate, let's say. Yeah. So for digital I/O on this device or on the our IoT edge gateway, you are what you are able to use is those input and output, of course, and then in this node rate. Let's say you have a node rate. We already have this ExamTech. They already have this a plug-in with the nodes that you can call the nodes to trigger I/O point or capture input, a digital input, a condition, status, or something like that. So that is going to be very useful. Another level is, so we have both Windows and Linux version that you can use in both of the platform. Plus AX eAPI, right now it's called DigiHub. Last time I think in one of the webinar we did a DigiHub. So DigiHub what you can do is give you an agent for you to do certain thing, but on a lower level, if you want to do your own C code, you can use our eAPI to do any capturing of input and trigger the output within the same system itself. This is also how the AI age application for this kind of device is useful, where you plug in another one of daughter board, you are able to do, in fact, most of the I/O point. But of course, my point here is limited lah. Limited. We have some system that already giving you isolation in terms of output. We have certain model lah. I think the ICO 520, yeah. So the latest gateway is already come with 8 input, 8 output. Those are isolation. With the isolation, they're already built in for you. But in order to make system or lower cost, usually they are all digital inputs. They are all digital inputs. So yeah, that's all. I think if you have any comment or if you have any question, you can also post to us. We are very happy to just talk to you. Or if I've said something wrong, maybe you also can point me out. Sometimes I talk, what I'm thinking like that, but I'm talking a different set, especially on the technical side. So I hope that actually I hope this set of info is useful for you. So yeah, so if you have any question, also you can also post to us. Okay. So for those of you who just watching us, we are on Let's Sembang AIoT episode number 29. Thank you for watching. So if you like this our channel, please do subscribe and like. Yeah. Like us, so and also share with some of your colleagues or your friends. Yeah. So at this point, until this point, I think our session will be more like information sharing and also some technical sharing. I think today maybe it's a little bit technical. Sorry for those of you who want to see more real life thing, but today I talk a little bit more technical in terms of electronics and IoT application. But let's move on to the other set. Yeah, I try to not letting Kenon speak too much because he's still on the coughing stage. Yeah. But I think he can do some of them. Yeah. So let's move on to the next stage where that is also one of the gateway router, in the 4G. Yeah.
So this one is a 4G gateway router.
Yeah.
So previously we connect this 4G gateway router to some sensor, and then once you put in the 4G SIM card, so it can do the Modbus pool either through the Modbus TCP or the Modbus RTU, and then you can send the data to your cloud. So here we have connected to this one is 4G antenna, a very big one.
Okay, I just want to talk about this antenna. This antenna is slightly having a higher gain. Usually what you have is something like that. Usually what you have is, okay, let me show you. This is one of the thing that usually you have something like that.
Something like this.
Oh, it's the same thing, but this one is a Wi-Fi. This one is a 4G. And okay, we have another spring type of antenna where you give you a cable of 1.8 meter or 2 meters. That is very useful with the magnetic. Yeah, that is the common thing that we ship our device.
Yeah, and today we connect to a temperature and humidity sensor here. And you also have a multimeter over here. So the purpose of this multimeter is later on we will demonstrate there's a new feature in this 4G IoT gateway. So previously, once the device do the Modbus pool, the information, the collected data will be immediately sent to the cloud, either through the MQTT or RESTful API. So, but there is some case where when this device you deploy at some area that you need to use the solar to power it up.
Low power thing, you expect for low power.
So in this case, you might not want to send the data very frequent, and then you try to reserve the battery power as much as possible. So in this case, the new feature over here is now you can set a time interval to put this IoT gateway into a sleep mode. So during the sleep mode, only the CPU is running, but the communication side, the modem side, it will be turned off. So, and during our experiment, we found out it can save around 50%.
Yeah, 50%.
Of the
So,
current.
so for those of you who has experience with 2G, 3G, and 4G, right now I think 4G will be a valid and also a more sustainable kind of application. Of course, no need to use 5G. Most of your IoT application you don't need to use 5G. 4G, with the 4G, you can have what it call most of your IoT application done within the 4G region. But a lot of people do not know that what kind of current consumption. Yeah. So after doing the measurement, you can see here is right now consuming about 110 to 130 milliamp.
Yeah, now it's
110 and 130 milliamp. And so when it's connected, roughly how much how much current is consumed?
okay. So when everything is connected to the 4G network, the current is around 200 milliamp to 300 milliamps.
Yeah. So 200 milliamp is get connected,
Yeah.
but when you transmit data, it can go up to 300 or more milliamp. So that part actually is what I call quite a power consumption, especially for remote site. That usually some of them they power on a solar or on battery mode. Some of them running on a battery mode. That will actually help you to cut down the half of the power.
Yeah.
So.
So as you can see over here now, the device is in the sleep mode. So the current consumption is around 100 milliamps.
Yeah, this is on the sleep mode case. So you see, okay, thank you, Gina. So although you can't speak loud, so I know, but then that part actually is quite fully explained. So of course, for those of you who use some of our product, we have a very good partners. This Hexa IoT. So one of them, they we are collaborating with them. If you want to have any solution on some agriculture stuff, on some they are very good in that. So you can also let us know. We will channel you to them. So that part is done, I think. So is there any more thing that we want to share?
No, I think
yeah. Just one last thing because this is a very tiny temperature and humidity sensors. It's talking mobile RTU. That's why it's able to fit into there. Of course, today we don't show you our this kind of dashboard because that's last time I think we show enough to you already. So let's see if let's say you have this set of requirement. I think basically today, just to recap, some I/O points. For example, some I/O point that you want to integrate into this device. Yeah. So you can have another I/O modules with the Modbus linking to this gateway, or linking to some of our IoT gateway. So you are able to publish data to the cloud. And also, or if you want to publish to the server, also fine. We can support REST API also, right?
Yeah.
So we are going to open more to different cloud platform. If those of you who are interested to do some collaboration, we are always you are always welcome. Yeah. So today is a very short one. I hope because Daniel is not feeling well also, but thank you for watching. And for some of you who has just watch this channel, we are going to have this channel every Friday, 4 p.m. Today is slightly late, some technical issue. We are going a bit late. And then also for those of you who want to get into some of this workshop, we have this workshop going on. If we have this workshop going on, this workshop is actually open to those fresh graduate, especially who want to get to know more about AI, IoT, what are the applications. We give a half-day workshop entirely FOC for you guys to get aware, how this IoT or AI, direction, especially in Malaysia, we are actually, I think government is putting up a lot of policy to encourage, especially in the talent development. Yeah. So I hope that will be useful for some of you who want to participate. You can always join us. Okay, I think a very short one from us today. Thank you very much again, and very important, keep healthy, yeah, and wish you a Merry Christmas and also a Happy New Year. Okay, see you. Bye bye.